Zero, the surprising foundation of all mathematics. Zero. The surprising foundation of all mathematics. Zero may seem like nothing, but it's the cornerstone upon which modern mathematics is built. You might think mathematics is built on giants like pi or e, but consider this. The most fundamental number might be one that represents nothing at all. This counterintuitive concept that zero, the absence of quantity, is actually the most important number in mathematics, is not just a quirky idea, but a profound truth that unlocks the deepest aspects of mathematical thought. The journey of zero from an obscure concept to mathematical superstar reads like a classic hero's tale. Around 5,000 years ago, the Babylonians used a base 60 system that couldn't distinguish between numbers like 1 and 61. This limitation created a problem until they invented a placeholder, the earliest form of zero, using two wedged marks at an angle. This simple innovation allowed them to indicate positional value, revolutionizing how numbers were represented. But this placeholder wasn't quite good enough. It would take another millennium for Indian mathematician Brahmagupta in 628 AD to treat zero as a number in its own right and define rules for arithmetic operations involving it. This was a groundbreaking development, though we still grapple with the concept of division by zero today, a problem that would eventually lead to the creation of calculus. The calculus connection, the development of calculus in the 17th century by Newton and Leibniz, represents one of mathematics' greatest achievements. Calculus deals with infinitesimal quantities, numbers so close to zero they're practically nothing, but not quite. This seemingly paradoxical concept allows mathematicians to perform what appears to be division by zero without actually violating mathematical rules. Consider a car accelerating according to the equation v equals t2, velocity equals time squared. Calculating the distance traveled involves finding the area under this curve. To do this accurately, you need to divide the journey into infinitesimally small time intervals. Calculus provides the tools to perform these calculations, revealing the true distance traveled as t33. This revolutionary approach, using infinitesimals to bypass the division by zero problem, has proven invaluable across countless fields, from physics to economics. Without zero and the concept of infinitesimals, these complex calculations would be impossible. Beyond arithmetic, zero as foundation, the true significance of zero emerges in modern set theory. In the late 19th and early 20th centuries, mathematics underwent a profound transformation as mathematicians sought to establish rigorous foundations for their field. At the heart of this foundation lies the empty set, represented as OR, which contains no objects. This seemingly simple concept allows mathematicians to build all numbers. Zero is defined as the empty set. 1 is the set containing the empty set. 2 is the set containing 0 and 1. This elegant system demonstrates that every number contains zero at its core. As mathematician Georg Cantor observed, the power of set theory is immense, and it rests on the simple concept of the empty set. Why zero matters today. The journey of zero from placeholder to number to foundational concept continues today. Modern mathematics, computer science, and physics all rely on the unique properties of zero. In computing, binary code, zeros and ones, forms the basis of all digital information. In physics, zero represents the absolute absence of quantity, serving as a crucial reference point. Even in advanced fields like quantum mechanics and cosmology, zero plays a fundamental role. Concepts like the Big Bang, which describes the universe beginning from a single point of infinite density, owe their mathematical formulation to our understanding of zero and infinity. Conclusion: zero may appear to be nothing, but its importance in mathematics cannot be overstated. From its humble beginnings as a placeholder to its current status as a foundational concept in set theory, zero has revolutionized mathematical thought. This unassuming number has enabled breakthroughs from calculus to computer science, providing the tools to understand and quantify the changing world around us. The next time you encounter zero, remember that it's not just a placeholder, it's the bedrock upon which all of modern mathematics rests.